You're at a really important moment in calculus. You really know all of the rules and all of the major functions that we're going to take the derivative of. So let's take this topic, 3.5, and just kind of lay them all out in one nice little reference sheet, see how they all work together, and then we'll kind of start moving forward with some more complex or more evolved topics with derivatives. But right now, after topic 3.4, you now know how to take the derivative of any function that's going to be given to you. So let's start off with our basic differentiation rules. And just to kind of throw out the disclaimers here, we're going to let u and v be functions of x. Let u and v be functions of x, and we're going to let c be a real number. Throwing out all the disclaimers here, c is going to be our constant value here in a moment. So c is going to be a real number, and n, which is going to serve as an exponent for us here in a moment. So c is a real number, and n is a rational number. Well, that means that the following rules are true. The first one we have is the derivative of a constant. We know the derivative with respect to x of any constant value c, which again we defined as a real number, is equal to 0. We have a rule for constant multiples. We can say the derivative with respect to x of any constant, so c, times, we'll go ahead and grab u. So a constant times u, a function of x, is equal to the constant times the derivative of u. So I can focus just on the derivative of this function of x and then multiply the constant times it. All right, we also have the power rule. This said that if I take the derivative with respect to x of u to the n. Now this may look a little bit different than when we did the power rule back in Unit 2, because now we're saying u is a function of x. Back when we did the power rule, we just had x to the n. So the thing that's going to be kind of brought into the fold here is the chain rule. So if I have anything raised to a power, I can bring the power down as a coefficient, times that function of x, reduce the power by 1. This is what we had originally, except u was x, but now we know we need to multiply by the derivative of whatever u is. So for example, if I have some function being raised to the 5th power, bring the 5 in front, reduce the power by 1, execute the chain rule. That's what this is now saying. If I take a look at sums and differences, well, the derivative with respect to x of u plus or minus v is equal to just simply the derivative of u plus or minus the derivative of v. And we've seen often that that's very handy when we start looking at things that are polynomial in nature, that I can take the derivative of each individual piece. We then have kind of our more complex rules from Unit 2. We have the product rule, which states that if I take the derivative with respect to x of u times v, and again, u and v are just functions of x, that is equal to the first, u, times the derivative of the second, plus the second, v, times the derivative of the first. So that's what the product rule looks like, and then the last one we'll put on here is the quotient rule, which says that if I take the derivative with respect to x, again, we're talking about u and v as functions of x, so we'll say u over v, that is equal to, and again, you can think of it low d high minus high d low over low squared. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Those were the basic differentiation rules we picked up from Unit 2. One of the things that we will be kind of working in, especially when we start talking about some of the functions in the next video, things like the trig functions, the natural log function, we need to make sure that we understand that the chain rule is working with all of these rules. So for example, the derivative of a function raised to a power, bring the power down, reduce it by 1, there's our execution of the chain rule. We're going to see u prime pop up a lot when we start talking about some of these other derivative rules, because we have to understand, we have to make sure that we are executing the chain rule when we're taking these derivatives.